welcome everyone to our public talk here, hosted by the Institute for Quantum Studies. It's really a pleasure today to welcome our speaker, a guest speaker coming to us from Ukraine, Dr. Gleb Skorobagatko. And I just want to give a little introduction into Gleb because he's a remarkable person and we're really happy to have him here. So he did his, he was born in the Ukraine and did his studies, his Bachelor of Science at the Kharkov National University in Kharkov, Ukraine, both his bachelor's and his master's degree. He did his PhD at the Verkin Institute for Low Temperature Physics and Engineering at the National Academy of Sciences, also in Ukraine. Then he did a postdoc following that in the Dahlem Center for Complex Systems in the University of Berlin in Germany, and then returned where he's now a member of the Institute for Condensed Matter Physics at the National Academy of Sciences in the Ukraine, and that's where he is currently. And I got to know Gleb several years ago because we have common research interests. We're happy to host him here at Chapman University. This was before the beginning of the Ukraine-Russia war, but we've been kind of pen pals since then, talking to each other about what life is like in wartime there as a scientist. And so we thought it would be a great opportunity to have him be able to tell us about his experiences in Ukraine, both from a scientific, but also from a personal point of view as well. So without further ado, let me then turn the talk over to Gleb and let him take it from here. So welcome, Gleb.
Okay, thank you very much, Andrew, for your brilliant introduction. Actually, you told a lot about my biography, which is also part of my story. I plan to tell you. And so, do you see? First of all, do you see the title slide of?
Yes.
Yeah.
Okay, and I I cannot understand how to see you, how to see the audience. It seems I can either see my slides or Zoom, but it's okay.
Yeah, but we are here, and
Yeah.
one of the attendees is Cristiano Silva. If you go to I don't know, his thing, you can see the audience. You can see Andrew.
I see.
We are all here.
Okay, I'll I try to do it because it's okay. Fine. Well, for me, it's a difficult, extremely difficult task to tell this story, just because it involves different aspects, and these aspects should talk to each other, and they should to give a sort of concise picture. But we discussed this with Andrew. Actually, it was his initiative, his brilliant idea to propose me to give such a talk to tell American audience in Chapman something about how science grown up in Ukraine and how scientists then go abroad, and then how one faced this war and challenges and some solutions. And I hope that this talk will be useful for American audience. Will be useful just because it's interesting human experience, interesting in quotations, just because it's sometimes tough, sometimes bright, and so on. Do you hear me well, by the way?
Yes, just fine.
Yes.
Okay. Well, and to start with, I discussed with Andrew this. So I told him I don't know how to bridge properly this experience with the American audience to be to give my point of view. But he told me profound words. You should be frank or honest, and that's way I try to do my talk. So that's why it will be a story. You see the outline, which how I see this story. This is approximately 30% biographical, 30% scientific, and 30% about war and wartime challenges, so on. Each story begins from the map. You can see here some important points important for me. So it's a Kharkiv city in the eastern part of Ukraine where I grown up 45 years ago, and there I grown up as a physicist theorist. Kiev, where we with my wife lived for a certain amount of time, and I do science there, being remotely in Lviv for several years, and several years spent in Berlin gave a lot in the sense of international collaboration and international experience and science. And another two important cities which are important in the sense of creative inspiration, and which is also a big deal now, this inspiration and this courage. It's a Paris where we were once, and Trieste region where maybe the spot which is known by everyone, that International Center for Theoretical Physics in Trieste. So let's begin. You can see the Kharkiv main square where the Kharkiv State University also is located. And this is, of course, pre-war photos from the peaceful times. I grown up there, as Andrew mentioned, and as I mentioned already. And as I studied in the end of 90s and the beginning of 2000 in this university. This university is famous since I'm physicist theorist. Of course, I studied physics on the physical faculty, and Kharkiv is famous by its theoretical physics school, which started from Nobel laureate Lev Landau in 30s. He left powerful school in Kharkiv. First of all, it's a Hiezer, Alexander Hiezer, who was the father of all Kharkiv theories for many years. And also Ilya Lifshitz, the brother of Lifshitz from the famous textbook Landau-Lifshitz. And he was the father of theoretical physics and in physical faculty of Kharkiv University. He was condensed matter theorist, and Hiezer was more like high energy theorist in Kharkiv Institute for Technologies. And now it's closer to my path. You can see here the building of physical technical faculty of Kharkiv University, where the Department of Theoretical Physics, Theoretical Nuclear Physics and Plasma Physics was located, where I studied, where I completed my bachelor and master degree. And this department is directly connected and led by Hiezer for many years. And after that, I started my PhD in the Kharkiv Institute for Low Temperature Physics and Engineering of National Academy of Science, which is also widely known, especially during the Soviet years, as one of the central spot for physics of low temperatures. Now, only theoretical part has been survived there. Just because of all this situation, even during the pre-war times. And this institute, Verkin LTP, had also powerful theoretical department, inspired by even by the mathematician part of institute, and is connected to the personality of Leonid Pastur, who led the theoretical department of Institute of Low Temperatures for many years, and during I was. So he was a famous scientist. He was a student of Ilya Lifshitz, and he was a famous scientist as a mathematician, as a physicist in the physics of Anderson localization and so on. And the second brilliant scientist in this department, I mean, the most noticeable person was Ilya Krivev, who was my supervisor. And there is a sort of genealogy in theoretical physics. So you see, Krivev was a student of Ahiezer, and Ahiezer was a student of Landau. Couple of words about my teacher, Ilya Krivev. As you can see, he was famous by things connected with quantum field theory, and he came actually into mesoscopic physics and quantum mesoscopic from the theoretical physics of elementary particles and quantum field theory and some kind of things. He collaborated during the Soviet years with many famous physicists like Andrei Linde, and so he was widely known. Unfortunately, he passed away several years ago, but he gave me a lot. Here you can see something from my past. Here it's Ilya office during my PhD years in 2008. We are there. I just completed the first paper by us and participated in conference. So here I'm like 28, and this, on the second photos there is the group of former collaborators in the times where I already did my own problems. You can see Ilya and our another collaborator of our group, Sergei Kurinich. So what kind of problems we try to solve there? I solved during my PhD years. I just gave these slides as illustration. So because the audience is expected to be broad, and the audience is mixed with professionals and people just who are interested in. So those who are more deeply in these things can read the slides, can learn some Hamiltonian, some formulas, but I just tell a few of words what is it all is about. So it's quantum mesoscopical physics, and it's my first area of interest in theoretical physics. It's a mixture actually of quantum approaches, quantum mechanical approaches, and macroscopical approaches. It's a situation when people investigate how quantum effects affect some macroscopic characteristics, as for example tunnel electron current. But electrons consider they are not as something averaged over big massive of particles, but as individual particles which can tunnel to the isolated molecule, for example, and then tunnel back to another lead of a system. And this requires certain theoretical apparatus which is mostly quantum mechanical. And we, in our problem, we especially were interested in quantum effects, which are part of these tunneling events when electron tunnels from one lead through the molecule to another lead. For example, here you can see the graphs from our paper there. We investigated how logarithmical velocity of swinging of a molecule is affected by quantum effects of emission and absorption of vibrational quanta, vibrons. Okay, do you see?
Yes.
Okay. There is a certain delay. Okay. Is everything okay?
Yeah, go ahead, Gleb.
Okay. Do you see and hear well? Okay. So the next problem is also about some effects of strong correlation, which affect electron transport in such systems. And this correlation result in some interference events between channels of electron tunneling. Well, that Kharkiv times was also bright. It was a starting of life. I met my wife Tamara there, and we had a bright period of short-term visit to the ICTP in 2011. You can see us young and full of joy. And another aspect was, of course, the processes in Ukraine, the revolution of dignity, Maidan, directly right before my German period. It was, you can see me on this, on the Maidan Square. So in Berlin, you can see our group where we studied quantum detection related physics and problematics. It's also maybe one of the leading centers in theoretical condensed matter physics in quantum mesoscopics, Dahlem Center for Complex Quantum System. I was invited there by Alessandro just to participate in his project about quantum detection. And the idea was to utilize my mesoscopical physics background to the problem how actually this molecule, which can be interpreted on qubit, how it precisely interact with quantum point contact, which can play the role of quantum detector. Of course, this interaction has two sides. One side is a signal from the qubit, another signal is a back action of quantum detector. And we were interested in, especially in the problem of strong correlation in such systems, like when you have a strongly correlated leads of your quantum detector, how this will affect the time scales of of decoherence and of acquisition of information. Well, our Berlin years were bright as well, so we explore surrounding and participate in some social activity. Here you on the Wannsee, a beautiful lake near Berlin. Where we enjoyed our walks and so on. And you can see also my wife Tamara on the meeting, on the pro-Ukrainian demonstration for peace, because the war in Ukraine actually started not in 2022, but in 2014, from the Russian invasion to Crimea and Donbass region, and people struggles from that as well. We were in Berlin that time, but some people from pro-Ukrainian community use this possibility to just to start to bring some messages to the Western audience about Ukraine. Well, here is a couple of illustrations of how nice and how inspired it was then during our European years. Just this couple of photos from our Paris vacations in 2015. You can see us here on the bridge near our beloved left bank and Latin Quartier. There we stayed, and the Cité Island. And for you know, before that we read the book about Paris, and we we enjoyed its location. And then we come to my Lviv period, also bright enough, and both in the sense of science and in the sense of new connections and new possibilities. In Lviv, you can see this ancient, beautiful city. I visited it before my German years. Do you hear me well? Yes?
Yes.
Okay. And the Lviv is connected with the Bogolyubov Scientific School. It's a bit another thing, more concentrated on first principle statistical physics, and you can see the building of the institute where I started to be affiliated. Importantly, you can see the funds in academia in Ukraine, Academy of Science, were limited even that time. In 2016-17 when we returned to Ukraine, and I need just affiliation to do science my way. And for me, that time was not principle in how to do this, in which format, remote or not remote. And that institute agreed to support the remote position for me. We mostly located in Kiev at that time, where Tamara, my wife, had her job, and she's a lawyer, but she started to work at the time in non-profit civil rights organization, and for her it was so also very bright and important period, which is beyond the subject of this talk, but it deserves another complete talk to tell about her. Well, and I visited Lviv from time to time and did some physics here on my own. Just like this, I continued my ideas on quantum detection, on quantum mesoscopic. For example, you can see this paper in PRB from 2018 myself, where I proved so-called self-equilibration theorem about plasmonic clouds which accompany quantum detection, decoherence, and tunneling via mesoscopic detection scheme. And surprisingly, the theoretical prediction of that paper, this step-like graph of detection, the quantum detector efficiency, gave a possibility for me to mention that this effect can explain some unusually long coherence time, which people observed in some experiments several years before that. So another completely new and very important block which I developed from 2017 till 2021 is a problem of how to find the universal criteria of separability or entanglement of arbitrary quantum multipartite system, where one knows only its density matrix in certain instant of time. So imagine you have only only you know about quantum system is the density matrix at given instant of time, and just a number, the table of numbers, and you can nothing about prehistory of this system before. You even don't know it's Hamiltonian, but using this separability criterion, if it is universal enough, just combining the matrix elements from this table of numbers and matrix from this matrix, and combining them into certain relations and following the sign of these relations, one can say whether entanglement took place in the prehistory of this quantum multipartite system. Of course, this first was rooted in the Peres and Horodetsky criterion or positive partial transpose. But what I did in that paper, I generalized this, and I noticed that by noticing that in any separable case, one can do partial transposition. It's a partial transposition, but partial transposition is a mathematical reflection of the fact that one can do local causality reversal in this case, in separable case. But other situation is an entangled case where one can reverse only time arrow as a whole, just because the states are entangled with the rest of universe. And this implies different logical relations between probabilities. You can see in the separable case in its symbolical form that probability of our ignorance about quantum state of a system is a sum of two possibilities. One possibility is a, say, spin flip, where a time or a general quantum transition between system state, where the subsystem evolves forward in time, and another when it evolves backward in time. But in the entangled case, situation is different. You should decompose not the ignorance probability, but the probability of generalized spin flip, which has in turn two possibilities: to be forward and to be associated with a forward direction of a whole time global time axis, or its backward direction. So another interesting topic which I developed at that time was the concept which I called as weak quantum evolution. So everybody in the audience, I think, know the concept of weak values, quantum weak values, which is associated with Yakir Aronov, with Weidman, and with Andrews' scientific activity, and many others. So what if system undergoes evolution, quantum evolution, where the outcome are weak values? So in a sense, weak values are the result of joint evolution of systems ensemble. And this led me to the idea of which I called weak quantum evolution. I just asked myself, what should be the conditions for this kind of evolution to have weak values as an outcome? And I found in this paper the restrictions for this. Sorry, how to return back? Oh, yes. I'm sorry. I have sometimes I have delays in the slides. Okay, is everything okay? You see?
Yeah. Yep.
Okay. And I found in this paper that one should deal with finite ensembles to in other words, the main consequence from this paper is that if the statistical ensemble is infinitely large, then weak values as outcome of related experiments can be smeared by another outcome. So the effect of weak values in that case will not be that sharp. That's why one needs finite, big but finite quantum ensemble. So this activity gave some results. That time I obtained the highest award for Ukrainian young scientists, presidential prize for young scientists in 2000. 19. The ceremony was held in Kiev in February 2020. You maybe all recognize this guy here. Now he wearing beard, Zelensky. And well, this is afterwards we with Tamara and me in the restaurant. There was the couple on the peak of success of activity. And another point was that time that I won the grant for which led us to the Chapman chapter, Chapman related Chapman of my experience. And I won the grant from the National Academy of Science to do research in the framework of a laboratory of young scientists in the institute. There are two young colleagues which afterwards took different paths. But we try to study the consequences of that previous ideas of mine about how this strong correlation effect, how they affect the statistics of tunneling electron. You can see some graphs we did there. Like we call this like tunneling maps of interacting electrons. And another the important turning point in my career was these conferences, which was where I was invited by Professor Yuval Geffen and Alessandro Ramita. These two persons, Yuval Geffen and Alessandro, they played enormously important role in my international part of my career, just supporting me. And you saw these Berlin years. And this conference was remarkable in many senses, just because I met first time with Andrew on that conference. You can see him here, and also another people from Institute for Quantum Studies like Karimi and Lev Weidman. And you can see here even this year's Nobel laureate Michel Devoret. So, and I was the only participant from affiliated in Ukrainian institution that time. And then in 2021, there was in the framework of my grant was my visit to wonderful 2 weeks long visit to Chapman, where I delivered my talk about universal separability criterion. And I met more closely with Andrew. I talked with Jeff Tolakson and enjoyed the very inspiring and I would say bright and relaxing atmosphere of Institute of Quantum Studies. You can see here also some times like I tried whale watching tour, but no whales I have seen, and this get together party here. So that's, and now we come to, from the first half of my talk, we come to the second half. But one can say why this all these preliminary things, career, why he told us about that. But to feel the difference and feel the challenges and explain to some extent how it was from inside, from my background. So everything seemed bright enough, but then Russian invasion to Ukraine started 24th of February 2022. War in Ukraine has begun. What is the war? First of all, war is a tragedy for human being, any human being. War in Ukraine is first of all human tragedies. Millions of refugees abroad and inside the country. You can see here cemeteries with the flags. It's a cemeteries of fallen Ukrainian soldiers. They are grown enormously across the country during this 3+ years of war. Dozens and then later even hundreds of thousands of victims of this war. Large pieces of Ukrainian territories occupied and devastated by Russians. Many big cities in the eastern part of Ukraine, including Kharkiv near the front line, experienced serious damages of its infrastructure, destroyed towns and villages in very many regions. You can see here the region council building in Kharkiv before and after this missile attack. And here, of course, huge flows of internal refugees from the eastern part of the country. You can see this famous photo on the right from the Kharkiv Central Railway Station in the spring of 2022. Hundreds of thousands of people were relocated just because in Kharkov things like this happened. This is a burning building of the Faculty of Economics of Kharkiv National University. And all these people pass through Lviv. Here you can see a Lviv Central Railway Station with full of refugees. Some of them go abroad, some stayed in Ukraine. As a result, despite many cases of help, huge growth of refugees caused a huge growth of amount of rent to rent apartment on the western part of Ukraine. Sometimes on the peak of this process in 2022, in 5 or 7 times higher than it was in peaceful time, and people should have money for this from certain sources, and nobody was ready enough to this. But even in the region like Lviv, during these 3+ years of war, one cannot say it's completely safe just because danger from Russian missile attack is real there. And you can see here the consequence of 2 such missiles attack in Lviv, one in 2023 and another in 2024, and 10 people died in each time. Just because, you know, in all big cities of Ukraine there are problems with the good bomb shelters, and people, the majority of Ukrainian people actually have no defense against this Russian attacks. So, and I heard both these attacks. So what kind of challenges Ukrainian scientists faces during this war? Of course, these risks for scientists and his family inside this war are common, are the same as for any civilian, because male scientists with PhD are not the subject of conscription, but still there are important nuances. Here you can see the results of destruction of scientific infrastructure in the eastern part of Ukraine, including Kharkiv. On 2 upper photos, if you remember, I showed in the beginning of my talk the department that I studied, the Department of Nuclear Physics, Theoretical Nuclear Physics of Faculty Physics and Engineering of Kharkiv National University, near Kharkiv and Petykhatki. And here you can see the same building as a result of missile attack. And this auditorium, one of the auditorium I studied in, so as a result. And here, well, and the natural solution is relocation for any scientist, but many scientists need to relocate. Relocation inside the country is very problematic just because scientists in Ukraine have very low average income, even lower than the average rent. If a person had no any grants from abroad, meaning international research projects or something like that, well, then how to survive in the war time? But the relocation would be a solution. Relocation, for example, abroad, participation in international scientific project. But unfortunately, there are also some sad nuances, which are very dramatical and very dramatical for myself. Closed Ukrainian borders during all these 3.5 years of martial law travel restriction. I think that this norm is completely useless, and it's very harmful for the entire national scientific ecosystem, just because, you know, science. I represented some important aspects of modern quantum science from Ukraine on the international stage, and I know how important this scientific communication is for any scientist to develop to protect family, to obtain enough income. And you can see here this logos of those organizations which proposed me during some short-term visit. And in the case of Sweden, it was a scholarship, 10-month scholarship to lead my own research project. And all this is either pending or wasted just because of this completely useless restriction. And here there are examples how I tried to deblock this situation in my case. Here you can see my official letter to the NASU president, and the official answer that, well, we can do nothing, it's beyond our possibilities. So what's the situation? Due to this activity or not, quasi-remote regime at my institute has been even pending in 2023. And as you can see, in such a way, because of war, one finds himself in a tough enough situation, staying for 3+ years inside the large-scale war together with my wife. Remarkably, Tamara refused to leave me for the European Union as a refugee. She stayed with me in a wartime country, sharing with me all dangers of this war. And for this 3.5 years, without any possibilities to use offline international scholarships, visits, being proposed exactly to help me to keep safe my family and to stay productive as a scientist. There's very limited initial income for rent and for relocation inside wartime country, etc. So what one can do? Can one stay in science even under such situation? And the answer is yes. If you are strongly supported by your beloved ones, Tamara in my case, by your common wonderful memories. Few days before the war beginning in the February 2022, I decided that we both should face it if it's happened, meaning war, in relative safety. We moved from Kharkiv to Lviv at that time, and later on, Tamara's safety was a priority for me. The rest supporting me was a priority for Tamara. And the answer is yes, if you are strongly supported by your friends and colleagues, mostly international in my case, if you have had a substantial understanding before. A number of good friends and colleagues of mine from the abroad and inside the country, those of different age and status, supported us during all these 3.5 and plus years of war, morally, practically, and sometimes even materially. Sometimes even a proper information about open possibilities of funding, scholarship, or remote grants can be very helpful. Some examples are shown below. And Andrew's initiative to arrange this talk is a bright, important example too. And you can see this information about scholarships, which I learned from my colleagues, and information about Institute of Physics Benevolent Fund, which provides money for physicists and strugglers. They helped me several times during this. And this is the first US-Ukrainian Quantum Forum where I delivered a lecture, and the paid me substantial honorarium for this lecture, which support us also. At last, the answer is yes. If you want to continue, follow your own way, your own professional scientific path. Then all the above creates what people are used to call as resilience. Because in such the case, you just cannot stop trying. And then you can find some funding for living and even for doing science, or at least try to do so. For example, with Andrew and Pavel, one Polish colleagues, we tried to write a proposal. It wasn't successful, but you know, it was a great experience too. And of course, Institute of Physics Benevolent Fund really helps physicists in critical struggles. As a feedback, certain feedback, indirect feedback, I've made for IOP journals a couple of reports as a reviewer. Well, and then you can continue to do some scientific research for yourself. And not only, I finished that paper by us about tunneling maps, which is open access, because for Ukrainian authors is open access in physics letters A. And I even did a sort of research, like a private research in 2022-23 about possibilities of photonic quantum gates. It's unpublished, but still I learned something new that time. And even to participate in some international conferences online, well, but still. Here you can see the title slides from 3 of these activities. Like one is first US-Ukrainian Quantum Forum in 2023, which was organized by Global Naval Research or Naval Research Global ONRG office, American office, which gave some money to support Ukrainian science, and they invited 14 lecturers, including me, from Ukraine to organize this small conference online. You can see the title here of my talk delivered in Lviv State University about quantum weak values and weak evolution, and the talk given on quantum detection problematics given last year on the conference in Poland, hypercomplex seminar. So now Ukraine, 22 October 2025, 3 years and 8 months of Russian-Ukrainian war. US President Donald Trump's peace initiative has gave its first results for Ukraine, definitely. Peace negotiations are about to start, and we all, people of Ukraine, hope this war will end very soon. Now, it's the final part of my talk, but the most important one. Important takeaways. You know, I never can imagine that I can formulate these takeaways in such a precise way. I didn't know that I have this experience, but I have it, and please read it, and I read it to you just because each point here goes from the depth of my perception of this war. And I sincerely hope this information will help any scientist in the wartime. Well, first of all, unfortunately, any big war is sudden. Prepare your mindset to take urgent decisions independently in advance. Like in our case, we removed from the eastern part in advance of Ukraine. Second, nobody provides you and your family as much safety as you can. Do as much as you can in advance. Relocation, search for apartment to rent, supporting each other, and take care about, for example, bomb shelters. And everything should be done in advance. Third, big and especially long war inevitably changes personalities in societies. Be ready to help and be ready to insist on following your personal way as well. You know, some basic civil rights even can be violated due to wartime conditions, and well, you should find yourself and conserve your personality, maintain your personality under such tough wartime conditions. Fourth, try to be not afraid of chaos, disappointment, and even shelling. It's probably the most difficult task. These all are side war effects if you survive it. The rest is only psychological effect. Keep your mind cold to take proper decisions. 5. There is no more close connection during the war than between you and your partner. The partner is your main treasure and your main support simultaneously. 6. You don't know when this nightmare war will end. Any war, in my opinion, but it is proved by what happens this year, has a sort of its energy, mindsets, money flows, politics, etc. And this energy inevitably dissipates sooner or later. Just find inner resources for the things that keep you as close to your pre-war self as it is possible. And at last, rephrasing Churchill, never, never, never give up your individual path if you're a scientist or another professional. Thank you for your attention and for your support.
Okay, thank you so much, Gleb, for that very moving presentation. Why don't we have some time to take questions from the audience about your experience? Maybe questions on the Zoom. We could also take those. So maybe I'll start just to get us going here. So you mentioned that there is this travel ban, so you can't leave the country. Who does this travel ban apply to? So some people have left. Who has left? Have they left legally, illegally? Can you tell us a little bit more about that?
Okay, it's a good question. Just because, as I mentioned, initially this travel ban was like for all male persons between 18 and 60 years old, but who are potentially subjected to conscription. But as I mentioned, there are some exclusions from this on the level of a law, from the level of national law. And all scientists with a PhD, working scientists, they are not subject of conscription. So like another categories of the person who are not eligible to be conscripted. The scientist should have a right to leave the country according to the law. But on the lower level of normative acts, as decrees of Cabinet of Ministers of Ukraine, they issued in 2022 a special decree which doesn't contradict the law, but it includes students and scientists from the category of persons who can leave the country without any explanations, against any reasonable arguments. But they did this. Maybe in such a way, universities and academy, they try to prevent brain drain during the war, but it's not a good measure, just because most international programs and grants have limits of time. These people they have necessarily to return back to the country just with new experience and new connections, and this would be good for scientific diplomacy, for many reasons, for development of Ukrainian science as well. But this stupid norm remained, unfortunately, unchanged during this all these years of war. Of course, one may say there are some exclusions. Well, some on individual basis, some scientists can get a sort of permission letters from the ministries. But here we come to the position of the National Academy of Science of Ukraine as a total organization. These permission letters issued by the Ministry of Education, they relate only to people from universities, but in a very restricted way, just for months only, and it's only for people who are close to governing slices of this universities and organization. But the entire position of the National Academy of Science is such they don't provide such letters. So they sort of keep the people without any reasonable grounds, and this is very harmful for the scientific ecosystem of Ukraine, in my opinion. Did I answer your question, Andrew?
Yeah, you did. Yeah. All right. Other questions? Oh, yes, from the back, Ibrahim.
Coming forward, I think the microphone is right. So, Gleb, thank you very much for sharing your thoughts and also the knowledge that almost, I would say, Western countries, they're blind to how challenges the scientists they face these days. Well, I'm coming from also war, so I've seen war. I know that war, what it will do with the people, and here we are worried about, let's say, publishing papers, doing scientific research. But at that time, I remember people that were fighting for survival. So just to be safe in a safe place, getting water or getting food. So it's amazing that still you're doing science. I really appreciate that. It's wonderful. Did you have any connection with experimentalists? Because I mean, the effect of coming back to the science on the theoretician will be very different on experimentalist. So you show the buildings, that the buildings that were completely destroyed. I'm sure that it will take years and years to build up such a building, and also even having power supply to the entire of these, let's say, the country or laboratories. Are you in touch with experimentals and following them, what they are doing these days?
Well, it's a very good question and very huge problem, just because, you know, I mentioned, you saw on one of the slides this institute, Working Institute for Low Temperatures and Engineering. That institute has a very powerful experimental, low temperature experimental base. During the Soviet times, then it slowly, during the times of Ukrainian independence, it slowly decays, but still there are many experimentalists there, and of course, their situation maybe should be much more difficult than the situation for theorists, just because, as you can imagine, in Kharkiv, any experiment is impossible. So people, either they use their, as far as I know, they use their international connection just to do some calculations, some computer modeling remotely or something like that, just because actual experiment is not possible, not only in Kharkov, but I think in any big center in Ukraine, like as Kiev and Lviv, just because of the lack of funding, and this lack of funding is only increased during these years of war, and also, you know, there's some air alert and the problem of conscriptions too, just because many people, many who are involved in the experimentalist activity, like engineers, they are subject of these conscripts, and some people even died on the war. So, and that's why I think this travel ban is very harmful for all the science, meaning it concerns experimental science maybe even more than theoretical, just because as a theorist I can, as you have seen, you can work remotely, you can do some things and you can be effective, but for experimentalists is very tough, I think. And we all hope that the war can end soon, and that's why things can return into to the normal mode, more or less. And of course, this actually it's a tragedy of Ukrainian science, you know, that because the science, despite the number of international projects, all these conditions scientists should work, and the lack of relocation abroad, just like one in principle on the level of state, they could organize sort of institution which have their filials, they have the part of the activity abroad, and on the basis of the, for example, European partner institution, and maybe some sort of this exists, but because of this travel ban for the large piece of Ukrainian scientific community, all this is should be very difficult. And if you want to know my opinion, my personal opinion, this 3.5 years of war and more gave huge negative impact on the entire scientific ecosystem of Ukraine to a degree which will be hardly to overcome during the subsequent years. I don't know how many years one needs to overcome this, 5, 10, or something like that, just because, you know, some students obtained the right to move to Europe, for example, to study. There should be the problem with younger generation of scientists in Ukraine. Older generation, people are dying, people become ill, people become demotivated. It's a picture of devastation, in a sense. Despite the attempts of separate peoples and separate authorities, maybe, but you know, this giant negative storm or something like that for everything which connects with science, knowledge, education, in a sense. Of course, as I said, on the official level, people try to maintain a facade of that everything is more or less okay, but the full body of this problem is frustrating. The only hope, in my opinion, is the growing international collaboration between those Ukrainian scientists who remain in Ukraine and their colleagues from Europe, from the USA, and if it will grow up further, and if people, the very important ingredient for Ukrainian scientists is the possibility to travel abroad. It's really a cornerstone of any success, or even not success, but for any maintenance of effectivity in the future. That's
Okay,
my
Gleb, I
opinion.
think we're out of time for the talk, but let's thank Gleb again for this very interesting. Okay, thank you very much, Gleb, and we'll talk again.
And thank you for your attention.
Bye.